Hello everyone. Wouldn't it be good if all of our electric systems automatically turned on or off without our intervention? Keeping that in mind, I made a simple automatic switching project which would turn the light outside your home on at night and off in the morning. I started with the schematic available online and assembled all the components on the prototype board and tested the system. There were a few issues with the design. One, the transistor PC548 had a peak current of 100 milliamps, which was not very far away from the operating point of the relay. So I replaced it with 2N2222A transistor with 800 milliamps as a peak current. So I was on a safer side. The second problem was the relay did not turn on and off at the intended intensity of light. So I decided to redesign the circuit. To start with, I used a variable voltage supply to find the current needed to just turn the relay on. I found that at any value above 40 milliamps, the relay turns on. So it was required for the collector current to reach 40 milliamps at the time when the light intensity fell down to the required threshold. From datasheet of the transistor, the current gain beta was found to be 200. So I divided the collector current by 200 and calculated the base current equal to 0.25 milliamps. Now it was required to find the resistance RL of the LDR at the threshold light intensity, so that above this resistance value, that is in lesser light intensity, the relay gets on, and below this resistance, that is at more light intensity, the relay gets off. By trial, I found this resistance RL to be 40 kilo ohms. So, marking this resistance as Rx, initially assuming the variable resistance Rv equals to 0 ohms and base current as 0.25 milliamps, I carried out some calculations with the supply voltage of 5 volt and found the Rx value to be equal to 16 kilo ohms. To provide further control over the switching time, I chose Rv as a 10 kilo ohm potentiometer. Also, remember that we will use normally open terminal of the relay and not the normally closed one. The relay was on PCB mountable, so I had to mark and put an extra hole on the perf board for the common terminal of the relay. After some adjustments, the relay was mounted on the perf board. That being done, I gathered potentiometer, perf board, relay, LDR, diode, transistor and some other stuff and assembled all the components together on the perf board and soldered them together. After this was done, the circuit looked like this. I took 2 jumper wires out for the DC power supply to the circuit. Also, 2 wires from common and normally open terminals of the relay were taken out. Our basic circuit was ready now. I wanted the DC adapter also to be placed along with this circuit. So, I took a 3-pin socket, marked 2 points and using soldering iron made 2 holes through it. After cleaning the holes, I traced the holes on perf board and created 2 holes on it too. I used nut and bolts to tie them both together and they fitted quite nicely. Before putting the circuit in a box, I decided to add one more feature to the project. I wanted the user to be able to switch the light on and off regardless of day or night also. So, I decided to add 2 switches to the circuit. One marked as switch 1 would disable or enable the circuit. Switch 2 then would let the user decide to power the light on and off after the circuit is disabled. The LED here indicates whether the circuit is enabled or disabled. There wasn't a perfect box size for the circuit, so I decided to make it myself. I took a cardboard from a carpenter, few M seals, cut out 6 pieces for the box faces, and joined first few faces using M seal. Then I cut out a part of cardboard for the switch 2 and fixed the switch using nuts and bolts. Similarly, I placed the switch 1 on the box 2 and fixed it by using M seal. Because of the additional circuitry, I had to make a few more connections in the basic circuit and put it inside the half-made box. I connected the wires to switch 2 and switch 1 according to the schematic. The potentiometer was also fixed on the box with the help of the nut provided with it. For the input wires, that is live and neutral, and the output wire, that is live out, I put a hole in the side of the box. Then I put a 3-pin screw terminal on it for these 3 wires and fixed it there using M seal. Then I soldered the described 3 wires to the 3-pin terminal, placed the DC adapter on the socket and made its connection. Now the circuit was almost ready, so I continued building the box again. I wanted to make the uppermost face to be openable, so I took a door hinge and connected one side to a cardboard piece, marked the other side on the cardboard box and made the holes for the bolts to go in. I forgot to place the LED on board. Doing a quick solder of resistor and LED with the circuit did the work. After that, I came back to the upper face and tied it using nuts on the box. After some scratching and removing some part of the cardboard, it did fit in the box well. Now to make the base stand, I took 4 pieces from a hot glue stick, attached them using M seal again, and the box was balanced well. With this done, our project was complete, but it looked quite ugly. So I covered its edges with black electric tape, and with little efforts the project looked quite fine. So to test the project, I used a cooler and placed all the connections along with the project on it. Now I turned on the main switch and turned on the switch 1. As we can see, the light turned on, which means the circuit is activated. Now we will, just to imitate night effect, put a hand on the LDR so that the cooler gets on. If I remove my hand from the LDR, the cooler stops again. Now we can cut the circuit off by switching off the switch 1, and now we can use switch 2 to turn the fan on or off. If we now switch on the circuit, the cooler turns on. So this way our project was successfully tested, but we still need to test it practically. So now we will use it for what it was intended to be used, that is, a light bulb. I made the same connections again, inserted the live and neutral into the first and second terminals, and took live output from the third terminal. I took 2 wires to power the LED bulb, hooked them up on the point extension on one side and to the LED on second side. After completing the connections, I just waited for the sun to go down and put the camera to watch the LED. As the night approached, the LED turned on automatically, though it was not dark enough to turn the light on. So I adjusted the potentiometer and waited for LED to turn on again. This time, the LED turned on at the right darkness level. It was difficult for me to wake up early to watch it turn off. So I just turned the room light on and the LED turned off automatically. Turning the light off, the LED lit up again. I tested the project for a few days continuously and it worked well, thanks to the clear weather. Because of its temporary arrangement, I had to take it off as rain approached. At least for some days, I got rid of turning on the light every day by going upstairs. Maybe in future I'll make full-fledged automatic system using programming microcontroller, timer, etc. with better capabilities. Till then, be curious and goodbye.